You're listening to DTF for August 9th, 2026. I'm your unlicensed and uncertified host, Jack Hacksman. We are your daily tech feed for Hacker News. A website W form of love is refusing to let something die. Today is about old ideas that were never actually finished, and the people stubborn enough to keep the receipts. Grab whatever's nearest and let's dig. In 1979, Dan Bricklin and Bob Frankston shipped VisiCalc. It didn't invent arithmetic. It just made a certain kind of arithmetic cheap enough that ordinary people started doing experiments nobody had bothered to run before. The math was old. The search became affordable. That's the pattern here. Sergei Gukov, writing at gukov.dv, went looking at magic hexagons. Quick primer. A magic square makes every row, column, and diagonal add to the same number. A magic hexagon does it for lines in 3 directions across a honeycomb grid. And there's exactly one non-trivial normal magic hexagon. 1. Order 319 cells. Numbers 1 through 19. Discovered, rediscovered, and proven unique. Because for any larger hexagon, the sum of 1 through however many simply refuses to divide by the number of lines. The arithmetic slams the door. Relax, one screw. Let the consecutive numbers start somewhere other than 1. And the door reopens. These are abnormal magic hexagons. And until very recently, finding them was pure brute expedition. The record set by Klaus Meffert in 2024 was Order 9. 9. Here's the move that changed it. Gukov didn't build a faster searcher. He shrank the thing being searched. Center the numbers on 0 instead of 1, so every line has to sum to 0. Then demand anti-symmetry. Put 0 in the middle. And make every cell the exact negative of the cell opposite it through the center. Suddenly, every line through the center cancels itself out for free. Every other line gets a mirror twin that's automatically solved the moment its partner is. Think of it the way a cathedral architect thinks about a flying buttress. You are not adding strength to the wall. You are redirecting the load into a shape that doesn't need the strength. The constraint stops being something you fight and becomes something you build with. Half the equations don't get solved. They get structurally obviated, and the result in the title is every order, not order 10, every one. The comedy of it is that the whole thing runs on symmetry, which is the oldest trick mathematics has. The AI-assisted part isn't a black box announcing a theorem. Gukov wrote the process down. The observations, the dead ends, the reframing, so you can follow it and disagree with it. That's the difference between a result and a method. A result you cite, a method you can pick up. One of the comments on the thread just says, hexagons are the bestagons. Correct on the merit. Hexagons earned their moment. Now, here's another kind of beautiful old thing getting new life. Pause. Story 2. What if the most subversive thing you can do with software is refuse to let it die? Someone named jmarshall23 took the leaked source to Microsoft Word for Windows 1.1a. Codename Opus, shipped in 1990, and ported it to native 64-bit Windows. Not emulation, not a virtual machine pretending to be a 3.6 of Evelyn, the original C source. Compiled, linked, running, as a modern X64 executable on Windows 11. Consider what that requires. Word 1.1a was written for segmented memory. That grotesque architecture where a pointer is a 16-bit selector plus a 16-bit offset, and deferencing it means asking the hardware where the segment currently lived. There's handwritten 16-bit assembly at the entry points. Double indirect memory handles because you couldn't trust an address to stay put. Every one of those assumptions is a load-bearing wall, and every one of them is false on X64. So the port translates the assembly into fixed-width C, maps the handle system onto a native runtime, rebuilds the original cursors and bitmaps and command tables with new host tools, and then, this is the part I admire, ships a test suite that drives the actual UI, typing, selection, formatting, dialogues, saving, automated proof that the thing still behaves like Word. Run this forward. If a 36-year-old word processor can be lifted across a fundamental architecture change by one person with CMake and patience, what's the actual argument that any software must be abandoned? The binary rots. The source doesn't. The only thing standing between us and every piece of software ever written remaining alive is whether the source is reachable, which is where the irony gets thick enough to spread. This is possible only because Word's source escaped. Microsoft did not publish it. Someone else made it reachable. And 36 years later, that reachability is why the work exists at all. Every year of proprietary lockup was a year this couldn't happen. A commenter asks how hard a Linux port would be. Another asks for screenshots. Someone notes the codename Collision. Opus was Word before it was a language model, both of them named after a word. And somebody just tried to build it and found a missing CMake file, which is honestly the most authentic possible tribute to 1990 software. 36 years of preserved code on one end, and on the other, a phone doing the job of a rack. Hardware keeps getting smaller while what we can save keeps getting bigger. Start with the constraint, because that's where this story actually begins. A general-purpose computer needs 4 things: cores, memory, persistent storage, and a network path in. The market has decided each of those has a monthly price. DRAM in particular has gone absolutely feral this year, which means the classic escape hat. Just build a box is closed for a lot of people right now. So the author of this piece looks around and notices something sitting in a drawer. A CMF Phone 1. 8 ARM cores. 8 gigs of RAM. 128 gigs of flash. Wi-Fi 6. A 5G modem. And, this is the part I love, a built-in battery backup. Every server rack in the world pays extra for a UPS. This thing shipped with one. The first attempt was the obvious one, and it was wrong. Flash Postmarket OS, get a real Linux user space. Done. The device port exists. It boots. There are green boxes on the compatibility page. There are also red ones, next to Wi-Fi, Bluetooth, and hardware acceleration. The exact 3 things a server needs: splash screen, then black display, then a soft-bricked phone, a Windows VM in QEMU, fighting MediaTek drivers over USB pass-through, and a genuine moment of believing you have manufactured a paperweight. The insight that came out of that failure is the whole article. Android already has working drivers for every strange vendor-specific corner of this hardware. Power management, the modem, the GPU, the battery controller. Vendors are terrible about upstreaming that work. So, throwing away the one user space that actually knows how to talk to the silicon in pursuit of a more familiar shell prompt is a bad trade. The goal was never to run Linux. The goal was to run Linux applications. So attempt 2 keeps stock Android and treats Termux as the host operating system. Open SSH, run it as the supervisor, caddy in front. Cloudflared and Tailscale for reachability. Termux boot brings the supervisor and SSH back after a reboot. Termux isn't a VM. Those processes hit Android's own kernel directly. But its Bionic user space is different enough that each app has to bring its own Linux file system along. That constraint turns into the architecture. Tiny control plane on the host. Applications carrying their own world. The result is a personal cloud running a remote browser, a finance tracker, screen sharing. Deploys from Git. Survives network changes. Costs $0 a month. That's a data center in your pocket, and you already own it. Now here's the same instinct pointed backwards in time. Pause. Someone decided in 1981 IBM XT deserved a real graphical operating system. 12 task slots. But prime. 1,536 bytes of stack each. A timer interrupt that takes the CPU away from whatever is running, whether or not that program consents. That is preemptive multitasking, and it's running on an Intel 8086. A chip from 1978 with no memory protection, no privilege rings, and nothing to stop a misbehaving task from writing straight over the kernel. It's called OS Gate man. It's called OS Gate man. Eat my man. Eat man to po beat wa be boot set. Relos good kernel and jumps to it. And what comes up is a Macintosh style desktop. Pull-down menus that stay open only while you hold the button. Windows you drag by a hollow XOR outline. A dock. A file manager. Minesweeper. A 4-channel Amiga mode player. Consider the details, because they're where the craft lives. There's no spare copy of the screen to restore from. So when a menu drops down, the pixels underneath get copied into a block, claimed off the heap for exactly as long as the menu is up. The drag outline is drawn in XR, which means erasing it is the identical operation to drawing it. The About box, the Control panel, and the Task Manager all read the scheduler mode from the same kernel byte on every repaint. So they physically cannot disagree with each other. Click Cooperative, and the very next timer tick simply declines to switch tasks. No restart. No handshake. Now the objection, and it's the one the comments went to first. This was written with Claude. Handwritten assembly, one reader noted. Or more like hand-prompted. Which sounds damning until you sit with it. Someone had to know that a 286 has no way to save the screen behind a menu. Someone had to decide that Doctile's position should be its table slot. Someone had to run it on real hardware and watch it not crash. The model didn't hold that architecture. A person did. And then there's the other comment. The honest one. It's funny how virtually everyone here is using AI to write code and simultaneously dismisses all interesting new software as written by AI. The whole thing is documented, page by page, on how the multitasking works, how the heap works, how programs load into their own segments at offset 0, so nothing needs patching. 48-year-old silicon, a desktop that shouldn't fit, and every technique written down for whoever wants it next. Speaking of things that shouldn't work but do, okay, that's Story 5's whole personality, and honestly, it's the theme of today's episode. Story 5. I built a system once that failed only under success. It worked fine in testing, worked fine at 10 requests a second, and fell apart the moment enough people wanted the same thing at the same time. That's the shape of this story. Shopify's oversell protection. The thing that decides whether 2 people can buy the last blue hoodie? Ran on Redis for years. Each item had a counter. Reserving decremented it. Releasing incremented it. Redis is very good at that. The problem wasn't Redis. The problem was that the reservation lived in Redis and the actual inventory ledger lived in MySQL. And there is no transaction that spans both. When payment succeeds and you need to deduct from the ledger and clear the hold, you do one, then the other, if the machine dies in between. And at Black Friday volume, something is always dying in between. You either sold something you never deducted, or deducted something, still marked reserved, overselling or underselling, chosen by whichever order you happen to pick. So they moved reservations into MySQL, where the ledger already is, and wrapped the whole thing in one transaction. Earlier attempts had failed because a single row with a quantity column becomes a lock convoy the instant traffic spikes. The new design uses MySQL 8's skip locked and stores one row per sellable unit. 10 units, 10 rows. Reserving 3 means grabbing 3 rows that nobody else has locked and moving them. No contention on a shared counter. The contention just routes around itself. Black Friday 2025, $5.1 million per minute at peak, 11% up year over year. It held. Here's the question nobody in the comment thread wanted to ask. Everyone argued about whether Redis is bad, or whether MySQL is fast enough, or whether this post was written by a language model. One person cut through it. This is a solution to a specific problem Shopify has. They never said Redis was wrong, and the honest lesson Shopify buried near the end. The real bottleneck wasn't what they were observing and measuring. That's the part worth carrying. You can rebuild the whole data layer, hit your throughput targets, ship it through the biggest traffic day of the year, and still find that the thing you fixed wasn't the thing you were watching. Your dashboard is a hypothesis, not a map. 6 stories deep, and every single one is about who holds the keys. Here's another, story 6. Right down to the exact model of disks in each machine. That's the line in Fastmail's announcement worth stopping on, not the headline. The headline is that you can now pick the European Union as the home for your email on servers in Amsterdam. The detail underneath is that they specified the disks. They bought their own hardware, co-located it in a secure facility, and their own engineers racked it. 25 years of doing it that way in Philadelphia and St. Louis, now in the Netherlands. Compare that to how almost everyone else ships an EU data region. You click a drop-down in a cloud console. You select a region string. Your compliance page updates. What you have actually done is rent a slice of someone else's machine and inherit their assurances as your own. Assurances you can't inspect, on hardware you can't name, subject to a corporate parent's legal jurisdiction that no region string changes. Ask the engineering question, who holds the off switch? For a rented region, the answer is the landlord, and the landlord's answer changes if the landlord's incentives change. Fastmail's answer is the company whose name is on the service. Encrypted at rest, inside locked racks, managed by an in-house team. That's a shorter chain of custody, and chain of custody up in this whole chain kudo custody, and chain of custody is the whole product when the product is your mail. And they told on themselves, which is the second thing worth admiring. The post says plainly that your resilient replica still lives in the US, because Amsterdam is their only European site so far. It says apps fail over to US servers if Amsterdam goes dark. They favor availability and they say so out loud. It says emergency backups sit in Philadelphia. If you need a guarantee or data never leaves the EU, they write, we don't have that and we'd rather tell you. The comment thread caught all of it because the post handed them the ammunition. One reader called it a good start. Another pointed at fully European providers. Both fair. But notice what made that conversation possible. A company publishing the exact shape of its own limitation in the same post selling you the feature. 2 copies in your primary location. 1 geographically separate. Hardware they specified. Honesty about the gap. Working infrastructure. Described accurately. Run this forward. That's the standard. Some days the through line is transparency. Other days is just people making things faster. Story 7 is the second kind. And honestly, that's a great kind. Make the case against this post first, and make it honestly. A commenter did. The write-up assumes you already know what a heuristic is, what admissibility means, why any of this matters. It drops you into triangle inequalities without a sentence of motivation. That's a real critique. Gatekeeping by omission is still gatekeeping. Here's why it fails anyway. Amit Patel learned this technique in 2007, tried to write it up in 2015, and stopped. Because his words. He didn't understand it well enough to explain it. Studied it again in 2016, 2018, 2019, 2022. Published in July, 11 years of refusing to ship a bad explanation. The critique is that the on-ramp is steep. The counter is that the on-ramp is steep. The counter is that the on-ramp exists at all. In public, with interactive diagrams, you can drag with your mouse because someone spent a decade making sure it was right. The idea itself is almost embarrassingly clean. Runs fast when the heuristic points toward the goal, and slow when it points into a wall, because straight line distance doesn't know walls exist. The perfect heuristic does. But you'd have to recompute it for every goal, so instead, pre-compute exact distances to one landmark. Call it the Eiffel Tower. Now, by the triangle inequality, the cost from you to any point is at least the cost to the tower minus that point's cost to the tower. Subtraction. That's the whole trick. Now run the principle all the way down, because that's where the comedy lives. If one landmark helps, more landmarks help more. Take the maximum. Every bound is still valid. Good. Keep going. Add 1,000 landmarks. Add 1 landmark per node. Congratulations. You have pre-computed every pairwise distance in the graph. Your heuristic is now perfect. A explores exactly the optimal path and nothing else. You have also built a table that is quadratic in the size of your map, and you have not written a pathfinding algorithm. You have written a lookup table with extra steps. The principle didn't break. It just kept going until it walked out the other side of the problem and became a different problem. 10 to 20 landmarks. That's the actual answer. The interesting engineering was never the idea. It was knowing where to stop. The math is free. The explanation took 11 years. Only one of those was scarce. Moving up. 2 comments on this thread, and together they do more work than the article. The first is pure warmth. It's good to reread Tom Halfhill. The second is a knife. Back when IA-64 was supposed to take Intel to the promised land, 1998. Halfhill is looking at the Alpha 211264. 64-bit, 700 megahertz, headed for a gigahertz. And asking a serious question. Whether RISC. Because in his snapshot, everything is collapsing. IBM and Motorola dissolving the PowerPC partnership. Silicon Graphics killing its next-generation MIPS. Sun porting Solaris to IA-64. HP porting HPUX to IA-64. The industry lining up behind one architecture that did not exist yet from a company that had never shipped it. Strip that to first principles. What did IA64 actually require to work? It required the compiler to find the parallelism ahead of time and bundle it into explicit instruction words, which means it required knowing, at compile time, what the memory system would do at runtime. That's the whole bet. And a cache miss is a fact you cannot schedule around, because it hasn't happened yet. Meanwhile, the 21.12.64 was doing out-of-order execution. Deciding at runtime with actual information in actual silicon. One design asked the future to be predictable. The other just handled it. The 2120/64 shipped. It hit a gigahertz. Merced slipped to 2001 and arrived slower than the chips it was meant to replace. Here's the part the retrospective usually gets wrong. Halfhill was asking whether RISC would survive, and the answer turned out to be an emphatic yes. Just not through any of the companies on his list. Every one of those architectures was somebody's proprietary asset, defended by patents, licensed at whatever the owner felt like charging. The instruction set was the moat, and when the owner's business model wandered off, the architecture went with it. Alpha got sold to Compaq, then to Intel, then to nothing. What survived is ARM, which decoupled the design from any single manufacturer, and RISC-V, where the specification itself is free, and a graduate student can tape out a core. The idea outlived every corporation that tried to own it. Because the ones that made it reachable are still standing. That's the durable lesson from a canceled Byte article. Architectures don't die of technical inferiority. They die of ownership. Now for something completely more fun. Someone figured out how to dither images into QR codes. And yes, they still scan Story 9. 1976, Robert Floyd and Louis Steinberg publish a 2-page item in the Proceedings of the Society for Information Display, describing an adaptive algorithm for spatial Gronkale. The trick is embarrassingly simple. You walk the image left to right, top to bottom. Each pixel gets rounded to black or white, and whatever error that rounding introduced. The difference between the gray you had and the black you committed to gets pushed forward onto the neighbors you haven't decided yet. 7/16 to the right, 3, 5, 1 to the row below. The mistake doesn't vanish. It gets distributed. Andrew Taylor's Dithered QR Codes take that 50-year-old idea and do something I find genuinely delightful with it. Start with the setup. A QR code has function patterns. The big squares in the corners that tell a scanner where the grid is. And data modules, the rest. There's a known trick where you shrink each data module to the center ninth of its cell, freeing the surrounding 8/9 for a picture. What you get is a photo with 1 pixel in 9 set to an arbitrary value. Salt and pepper. Noise you cannot remove, because that noise is the payload. Taylor's move is to stop treating it as noise and start treating it as error. 2 passes. The first pass walks the image and forces every data module to the color the QR spec demands, and then diffuses that error outward to the 8 surrounding pixels, exactly like Floyd and Steinberg. If a module in a dark region has to be pure white, that's a 95% error, far larger than anything ordinary dithering produces. Doesn't matter. The neighbors absorb it. They go darker to compensate. The constraint becomes part of the picture instead of a defect on top of it. That's the craft. A hard external requirement, folded into the same accounting the algorithm was already doing. And the reason anyone can do this at all. Masahiro Hara's team at Denso Wave published the QR specification in 1994 and declined to enforce the patent. It became an ISO standard. No license, no scanner certification, no permission. Which is why the format survived barcodes that were fiercely defended, and why a person on the open web can spend a weekend teaching a 50-year-old dithering kernel to respect it. The commenters found color versions, animated ones, diffusion models generating scannable art. That's what happens when the spec is yours to poke at. Now for something with considerably more voltage. Story 10. What does a container terminal actually need from the ground beneath it? Not strength exactly. Confinement. Here's the distinction. Sand in an open pile can hold almost nothing. Press down and the grains slide sideways along a shear plane. The soil moves down, then out, then up, and whatever sits on top tips over. That's bearing capacity failure. Now take the same sand, the same grains, no change in material at all, and pour it into a bag. It gets stiff. It carries load. You haven't strengthened anything. You've removed the direction the failure needed to go. That's a geocell, a honeycomb of plastic strips, unfolded across a site like an accordion, filled with whatever soil is lying around. When a wheel presses into one cell, that cell tries to spread. The walls resist it in tension, and the neighboring cells push back through their own fill. Load applied to one pocket gets distributed sideways across dozens. Think of a wine cellar's barrel vault. The stone in an arch is doing nothing but sitting in compression. Its strength comes from geometry constraining where it can go. Geocells do the same thing in reverse, in 3 dimensions using tension instead of thrust. Port of Long Beach, early 2000s. Pier-T terminal, expanding into an old dry dock that sat well below yard grade. The available fill was dredged marine silt. Waterlogged, structurally close to worthless. The conventional answer was excavate it all. Truck in a mountain of imported aggregate. Spend millions, spend years. Instead, they laid geocell and filled it with the junk that was already there. The finished platform carries 100-ton cranes and stacked containers. Grady built a model in his garage to show it. That's the part worth noting. The whole discipline of geotechnical engineering is people working with materials they didn't specify, can't return, and have to characterize before they can trust. Nobody gets to order better dirt. One commenter left the entire response. Interesting concept, horrible writing. Sometimes the mechanism carries the segment on its own. This has been your daily tech feed for Hacker News for August 9th, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voiced by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go finish something old you never finished. We'll see you back here tomorrow.